For several years, my students have focused their independent research projects on sustainability and the promotion of biodiversity. In 2019, Kristen Ruzicka designed and constructed a rain garden that processed the runoff from one of Maryville's parking lots. Also in 2019, Catrice Kolb found that increased flooding of the Merrimack River was associated with increased construction of levees as opposed to increase in temperature. In 2020, Ellie Paul showed that the addition of a filter could reduce the nitrogenous runoff from the university's freight farm. Also in 2020, Jennifer Van Boeven showed that rainwater collected from roofs with asphalt shingles was of low quality, but it could be improved with either a filter or through solar treatment. And finally, in 2020, Diego Hernandez evaluated Maryville's carbon footprint and showed that in the student apartments, Maryville could reduce the amount of money spent on appliances if they installed energy-efficient appliances. It's worth noting that all 5 of these projects had intentions of being presented either at NCUR or the Missouri Academy of Sciences, but those plans were upended by COVID. Our current projects are focused on biodiversity and sustainable gardening. The first is on no-till methods for gardening. For this project, we are laying down cardboard, drilling holes in the cardboard, planting seeds, and then covering with a light layer of mulch. This should reduce watering needs and increase soil biodiversity. We're comparing plots with cardboard to plots that are tilled and looking at total plant growth. This picture was planted with beans, and you can see that it didn't work so well because squirrels came in and dug up all of the beans. But this is an adjacent plot with corn, so corn did really, really well. In the next project, we're trying to use birds, or at least recruit birds, to come in and control the cabbage moth larvae that tend to destroy plants in the Brassica genus. Pictured are a couple cabbage plants that have just been completely destroyed by those larvae. In the first phase of this project, we are planting our Brassica plants alongside different combinations of wildflowers with the goal of recruiting songbirds. Observationally, we've seen birds eat cabbage moth larvae. We just need to find a way to let the birds know that this is a reliable place for them to find food. And this has been a little bit tricky thus far because we need something that will attract birds very, very early in the spring as well as late into the fall. So far we have several candidate mixes of wildflowers, and it looks like they are actually effective in recruiting songbirds beginning in year 2. In the next phase of this project, we're adding birdhouses to try to increase the breeding density of birds near brassica plots. So we're growing birdhouse gourds, curing them and treating them, and then mounting them near our brassica plots with the goal of attracting species like wrens, chickadees, tufted titmice, and bluebirds. But you'll notice on this birdhouse, I have gutter mesh in a circle around the opening to the house, and that's because in St. Louis we have Eurasian tree sparrows. Even though the goal was to attract native species, instead what we've done is increase the breeding density of Eurasian tree sparrows. And so now this project has a new goal, and that is to build houses and hang houses that will recruit native species but exclude tree sparrows. And so far that has proved to be incredibly difficult. But we are making headway basically by making holes that are small such that only wrens and chickadees can use them and tree sparrows can't. Another project is focused on using sustainable methods to deter browsers like deer and rabbits. Initially we did experiments where we sprayed hot pepper extract on garden areas where we wanted to deter browsers. Unfortunately, the deterrence of hot pepper extract was very short-lived at best. Recently, we've discovered that plants that are planted near agave plants tend to be protected from deer. So this sunflower in the middle of the screen was not browsed, but all of the other sunflowers were browsed. So while chemical deterrence appears not to work, physical deterrents, like agave plants, does work. And it works on deer. We have yet to discover anything that's effective for rabbits. Now we just need to cultivate enough agave plants to do an actual experiment. And finally, we have a project focused on the class of herbicides known as 2,4-D. These are known commercially as picloram, dicamba, and they're found in herbicides that people spray on their lawns like spectricide. The effect, as you see in this tomato plant, is to cause increased rates of plant growth, uncontrolled, unregulated plant growth, which leads to gnarled leaves and flowers, and it basically kills the plant. And it's intended to kill broadleaf plants like tomatoes and peppers. 2,4-Ds have become more and more popular recently, especially as weeds have become resistant to glyphosate. 2,4-D chemicals are particularly problematic for a few reasons. One, they biodegrade very, very slowly, so they remain in the environment for very long periods of time. They're effective, they're highly effective at very low concentrations, so it only takes a tiny bit to kill one of your tomato plants. And they're highly volatile, so one of your neighbors or even somebody a mile away could spray 2,4-D on a hot day, and it could drift into your yard and destroy all of the broadleaf plants in your yard. Growing pepper plants and growing birdhouse gourds are essential to some of my student-based research, and both of those things have been negatively impacted by drift from 2,4-D. We've lost lots of pepper plants and lots of birdhouse gourds. Despite massive lawsuits against companies like Bayer and Dow that are making these 2,4-D chemicals, it appears that 2,4-Ds are going to be with us for the long run. And so we have to find ways to cope with them. We have to find ways to garden in the presence of 2,4-D. Last summer, by chance, we noted that the blue bean hyacinth appears to be resistant to 2,4-D. So plants around it were dying, but the blue bean hyacinth was fine. In addition, a pepper plant growing in the same pot as the blue bean hyacinth appeared to thrive. That is to say, it appeared to survive the 2,4-D exposure. So this summer we have an experiment going where we have a bunch of plants that are growing with a blue bean hyacinth in the pot, and a bunch of plants that are not, that don't have blue bean hyacinth. And we're going to look at growth and survival. And there's much more to come. Thank you very much.